In this video, we're going to look at the arc length and the speed of a parametric curve. So let's say you've got a particle that starts here at time 0. So this particle is going to move along this path. So let's say at this point here, the time is, let's just say the time is this. So a small increase in time would result in the particle moving from here to here. So we can approximate that to this. So a small increase in time, you can say that the particle has made a vertical distance of, let's say, dy. So and then a small increase in time, you can say that the particle has covered a horizontal distance of dx. So a small increase in time, you can say that the particle has traveled this amount of distance. Well, because time is tied into the whole thing. If you've done this much amount of distance, so dy can also represent the distance that the particle has covered, the vertical distance. Well, because time is tied into this whole thing here, then you can say the speed is dy by dt. Because hang on, a small increase in time would result in a distance of dy being covered. So if you've covered this much distance, let's say 6 meters in a small amount of time, let's say 2 seconds, then your speed will be 3 meters per second. You see, if you've covered a distance of dy, a small distance of dy in a small amount of time, then this thing here can represent the speed in the vertical direction. So a small increase in time, let's say dt, a small increase in time would result in a small amount of ground that has been covered in the vertical direction. So you can say that a small increase in time would result in this much ground being covered in the vertical direction. But then you can also say that the speed would be dy by dt, because if you've covered this much ground in dt amount of time, then this thing here can represent the speed. And the same argument goes in the x direction as well. So a small increase in time dt, you've covered this much ground, you've covered this amount of ground dx. But then if you've covered this much ground in this amount of time, then you can say the speed, the horizontal speed is dx by dt. So you can actually make this statement. Now imagine you are the particle moving along this line here. Now this actual path, let's just say that's the actual path here is ds. Well, now imagine you're the particle, you've moved this much distance, so you've covered that much distance in this amount of time. Then this ds by dt represents the actual distance covered in the amount of time, the actual speed of the particle going along the actual path. Okay, so you can actually make this statement. Hang on. You can actually make this statement. A small increase in time. Hang on. So a small increase in time would result you making a small increase in the y direction. But then because time is tied into the whole thing, then the speed will be delta y by delta t. So that's this bit here. And then in the x direction, you've covered this amount of distance in this amount of time, then this would represent the speed in the horizontal direction. And then this ds here, remember s is the actual path that the particle has taken. Ds or delta s represents the actual path. Okay, not the approximation, not the straight line, but the actual path. Delta s represents the actual path. So the actual path in the given amount of time is this. So you can say the actual path is approximately this whole thing here, because it's really you using Pythagoras. So the actual path here is this, but you're going to approximate that to Pythagoras by using Pythagoras. So get this speed, square it, and then get this speed, square it, and then the actual path here is approximately so you can make this statement here. Okay, that's very similar to you being in high school. When you were in high school, you were given a problem similar to this. You're in a boat traveling horizontally at 4 meters per second, and the current of the river is flowing 3 meters. Now, 3 meters per second. Then you can say the resultant speed would be you using Pythagoras. You see, you use Pythagoras here with speed. So you should be able to do the same here as well, because so this here is your x direction, and you're talking about a period of time. So that's similar to dx by dt, and this is the vertical distance, which is dy, and then you're talking about a period of time, dt. So you can still use Pythagoras on dy by dt and dx by dt. You see, even though it's a speed which is dx by dt, we can still use Pythagoras, because you were comfortable with using Pythagoras on this. So you should be able to accept that we can use Pythagoras on this as well. So dy by dt, we can use Pythagoras on this as well. Okay. I will continue in the next video.